Chapter 3.2 is graphing now using the x and y intercept. So chapter 3.2. Now remember, the x-intercept is always going to be the point, if I can allow me to do this, a comma 0, where a is the solution I found when I solved for x, when I plugged 0 in for y. So when you're finding the x-intercept, the first thing I do is plug y equals 0 into the equation. Then you solve for x. And x is going to equal some number. And then you want to make a point, and that is going to be that number, comma 0. Because remember, a point is always x, comma y. The x is going to be some number, and the y was 0. So that's the x-intercept. Then the y-intercept is the point 0, comma b. Okay, so the first thing you do here is plug x equals 0 into the equation. Then you're going to solve for y. So y is going to be some number now. So the point is going to be 0 because x was 0, and b because b is some number. Okay? So remember, the x-intercept is where the graph crosses the x-axis, sorry. Oh gosh. Hold on. Oops. Alright, so the x-intercept is where the graph crosses the x-axis. I don't know what's wrong with my pen. And the y-intercept is where it crosses the y-axis. I hope I'm going to be able to write. There we go. Alright, so let's do some problems. Let's first look at, on page 270, number 10. It says, use the graph to identify the x-intercept, and part B says the y-intercept. So I'm looking at number 10, and I'm not going to draw the graph, you just have to look along with me. Now, what you want to look for is where does the graph cross the x-axis? Where does the graph cross the x-axis? So you know what, I will draw it. So let's see if I can draw this real quick. Hopefully. And alright, that's the best I can do. Okay. Awesome. So let's see here. The x-intercept is where the graph crosses the x-axis. So let's figure out which one of these axes is the x. The horizontal is the x-axis. So where does the graph cross the x-axis? Right here. What is that point? Is -2. So the x-intercept is -2. So part A says find the x-intercept. It's -2. That's where it crosses the x-axis. Now, the y-intercept is where the graph crosses the y-axis. So let's get another color. This is the y-axis, so it's down here. 1, 2, 3, 4. It crosses here at 4, which means the y-intercept is -4. So the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. Hope I said that right. Okay. Look at number 11. So number 11, I don't know what's going on with my pen. Let's see here. Alright, so number 11, now I'm looking for the x-intercept as well as the y-intercept again. And let's see here. Does the graph cross the x-axis anywhere? The answer would be no. Therefore, it doesn't have an x-intercept. The x-intercept means it has to cross the the x-axis. If it doesn't cross the x-axis, then I don't have one. So part A would be no x-intercept. No x-intercept. Okay? Then part B says, well, where's the y-intercept? But does the graph cross the y-axis? It does right here. And what is that? It's 1, 2. So the y-intercept is 2. Good. So remember, when you're identifying the x and the y-intercept using graph, you're just looking for where does it cross the x-axis, where does it cross the y-axis. Alright, so now let's practice, let's see here. We're going to practice graphing a line using the x and y-intercepts following these steps. Okay? So let's look at let's go for number 16. Alright, so number 16. I have the equation 3x minus y equals 0. And what I want to do is I want to find the x-intercept first. Well, the x-intercept says you got to first, everywhere you see a y, you got to make a y equals 0. So it's 3x minus, instead of y, now it's 0, equals 0, which means I have 3x equals 0, divide by 3, divide by 3, and I end up with x equals 0. So the x-intercept is 0, 0. Awesome. Now let's try to find the y-intercept. We're going to do the same thing, except for now we're going to have x equals 0, and we're going to solve for y. So 3 times 0 minus y equals 0, which means negative y equals 0, which we have y equals 0. So the y-intercept is also 0, 0. Which means we're at the same point. But how am I going to graph this if I only have one point? What you'll have to do is pick another point. Just another point, any point. Just like you did before in 3.1. You pick the x and you solve for y. So how about this? Choose x to be equal to, I don't know, 1. Yeah, 1. Good. And what we're going to do is solve for y. So 3 times 1 minus y equals 0. Remember, everywhere you see an x, you're going to make it a 1 and solve for y. So I have 3 minus y equals 0, which means y equals 3. So now I have the point 1, 3. And I can graph. So remember, you always got to have 2 points to graph. If your x and your y-intercepts are equal, you got to find another point. So the point 0, 0 is at the origin. Good. And the point 1, 3. So 1 to the right and 3 up. 1, 2, 3. 1, 2, 3. 1, 2, 3. And there's that point, and then connect them. And there's your line. Good. So remember, in order to find the x-intercept, everywhere you see a y, you're going to make it a 0, and then you're going to solve for x. To do the y-intercept, everywhere you see an x, you're going to make it a 0, and then you're going to solve for y. And now normally these points would be different, and at that point you would graph your 2 points. Sorry, there's a lot of points in there. How about this? Normally these points would not be the same. And if they weren't the same, you can go ahead and graph them and connect them because that's 2 points. In this case, they were equal, therefore I had to find another point. And remember, when you find another point, you choose the x, and the y comes out because it depends on the x. Okay, good.